this theorem here and this one are the same, right? This one is just a direct one. It tells us that if you draw a line from the center and you make that line perpendicular to the chord, or rather perpendicular to a chord, then the line drawn from the center will be perpendicular to the chord. Now the converse is just the other way around. And now this time a line is drawn to bisect a chord. So a line bisects a chord. A line through the center bisects a chord, which means the line through the center should be perpendicular to the chord. Because this line through the center bisects the chord, then that angle there should be 90. So you get questions that ask you to prove that angle OPB is 90, for instance. One way to know that that angle is 90 would be for you to remember that the line through the center is bisecting the chord. If the line through the center bisects the chord, then the angle should be 90. What about this theorem here? A perpendicular bisector of a chord passes through the center of the circle. Does that follow from the last two sections that we spoke about?
Yes.
A perpendicular bisector of a chord must pass through the center of a circle. Does it make sense?
Yes, it does.
Right. Because if you look here, this line here is called a perpendicular bisector of this chord. And that line must pass through the center, right? So how do I prove that a line passes through the center? If the line bisects the chord, then it must pass through the center. Do you agree, guys?
Yes.
Bisect how? Just bisect.
From the center. From the middle of the, I don't know.
It must bisect perpendicular, right?
Yeah.
It should bisect perpendicular. Because look at this. If I draw this here, this is a chord here. Maybe that is the midpoint of the chord. This line that I'm trying to draw here, do you agree that that line bisects that chord?
Yes, sir.
But the only line that will pass through the center is the line that bisects the chord perpendicularly. So I know that this line here should pass through the center. It passes through the center because, number one, it bisects this chord, as you can see, and it bisects the chord perpendicularly. All lines that bisect the chord perpendicularly must pass through the center. So even if the center is not marked, I know that the line will pass through the center. So do you see that we can ask you guys to prove that a line is a diameter?
The diameter is the full line.
Yeah. For instance, you give a line like that, and there's so many other lines, right? And I might actually ask you to prove that that line is a diameter. Obviously, I'll give you some other stuff somewhere. I'll give you more information somewhere. So, do you agree that CD is a diameter?
Yes, sir.
CD should be a diameter, right? Why is CD a diameter? Or in other words, CD is that special chord that passes through the center. How do we know that CD is a diameter? Yes.
We can conclude that CD passes through the center of the circle because it bisects the chord at 90 degrees, and therefore we know that it would be a radius in because it touches both sides.
Okay. So first of all, CD, C is on the circumference, D is on the circumference. This line CD bisects that chord, and it bisects the chord perpendicularly. So that line CD should pass through the center, but because it is from circumference to circumference, it should be the diameter. Then there is this other theorem. Remember, we are interested in the theorems that have to do with the center of the circle. What did we say about this one?
Q1 will be double C2.
That O1, angle O1 is equal to?
2 times C1.
Right, that angle O1 is equal to 2 times angle C1. And when you write your reason, for instance, you're working out something here and you're saying angle O1 is 2 multiplied by angle C1, what reason are you going to give that?
Angle system.
Angle at center equals 2 times angle at circumference.
So you're going to say angle
At center
at center
equals 2 times
is 2 times
angle at
Okay, good. Right, so the angle at the center is 2 times the angle at the circumference. You need to do that. You don't have time to write a whole paragraph like that. Okay, the next one after this is related. It's related to this one. It comes from this one really. Angles that are subtended by the same arc or by the same chord at the circumference should be equal. This arc here, this arc subtends angle O1 at the center, but again the same arc subtends angle A at the circumference. Now the same arc PQ subtends angle B at the circumference. So if O1 is twice A and O1 is twice B, so this is what we have. So angle O1 is 2A and angle O1 is 2B, which means 2A should be equal to 2B. It follows from that, which actually means A should be equal to B. So these angles will be equal, because these are angles that are subtended by the same arc at the circumference. Right. Suppose this is equal to 3x and this is equal to 60, and they ask you to find the value of x. How do we find x here? Maybe let's answer that question.
3x is equal to 60.
So you say 3x is equal to 60, right? So this is your statement. 3x is equal to 60. And what is your reason?
Angles in the same segment.
You can say angles in the same segment. The segment is, if you look at PQ, this here is a minor segment. Then the other one is the major segment. So we refer to these two as angles in the same segment. So you can give your reason like that. That is fine. How else can you give your reason? If you don't want to say angles in the same segment, you can actually say angles subtended by the same arc at the circumference, right? That's wrong. So these are angles subtended by the same arc at the circumference. Otherwise, you can say angles in the same segment. Then this one, an angle subtended by a diameter at the circumference is a right angle. That should make sense from the previous one. If you consider this arc here, now that arc subtends 180 degrees at the center, but this same arc subtends angle P at the circumference, and we just said the angle at the center should be twice the angle at the circumference. So that should be 90 degrees. Right. Okay, so here we are saying a diameter, so this diameter subtends 90 degrees. So if I start here now, if this angle is 90 degrees, then that chord should be a diameter. Do you see that? So a chord that subtends 90 degrees at the circumference should be a diameter. It is only the diameter that can do that, right? So that is why the converse will read something like this. A chord subtending a right angle at the circumference is a diameter. So when you see this, you need to know AB should be a diameter, because that will not happen for any other chord. So this is a corollary. So here is a circle. This chord is marked equal to that chord. And this chord subtends at that angle there at the circumference. This one subtends something there at the circumference. It follows that these angles, these equal chords will subtend equal angles. How would you prove it very quickly? Obviously, if this chord is the same length as that chord, suppose you knew the center, you could create an angle at the center, which is subtended by this one, right? Right. So if this angle, for instance, is 40 degrees, then what will that one be?
20.
So that one will be 20. Now, because this is the angle at the center, but that is the angle at the circumference. So do you see how it follows from the previous theorems? So the angle at the center should be twice the angle at the circumference. Now, if this chord is the same length as that chord, so if I draw an angle at the center, subtended by this same chord, do you think this angle will be different from this one? This angle will be the same, right? So this angle will be 40 as well. So if this angle is 40, then what is that for? That angle there? So that angle there is 20. So we are saying equal chords or equal arcs should subtend equal angles at the circumference, right? And the other corollary is this one. Equal chords will subtend equal angles at the center, right? So if angle O1 is 40, then angle O2 must also be 40. Here's a third corollary. It says equal chords of equal circles subtend equal angles at the circumference. So the question is, what do we mean by equal angles? Sorry, equal circles. What are equal circles? Do you see this circle here? Suppose it has a radius of, let's put a number. Suppose this has a radius of 5 units. And this one also has a radius of 5 units, right? Okay, we will call them equal circles. In other words, two circles with the same radius should be equal. Kind of congruent, eh? Yeah, kind of congruent. So equal chords of equal circles subtend equal angles. So here is a chord which is the same length as that one. So this one subtends angle A at the circumference. That one subtends angle B at the circumference. And we are saying these angles at the circumference will be equal. We can do most of these questions orally now. Like, you can tell me that x is 30, do you agree?
Yes, sir.
What is the reason?
Angle between the centers twice the angle at the circumference.
Angle at the center is equal to 2 times angle at the circumference. Just practice writing that kind of reason. So yeah, x is 30. What about this one? X is 48, yes. X is 48. What is the reason?
Angle
Angle at the center is twice the angle at the circumference. Okay, good. What about this one? What is x equal to? X is equal to 20, right? X is equal to 20. What is the reason? Right, angle at the center is twice angle at the circumference. And that one?
75.
Same reason.
75.
I don't agree.
Now that's double. It will be 150 plus 150 is 300.
X times circumference.
No, it's not 75.
Oh, it's because they look, there's more than two.
Keep quiet.
And now, guys, this angle is not half of 150.
50.
It's not half of 150, but it's half of
And both things.
that angle there.
Oh, you got
Keep quiet.
So
So is it 90?
equals 2x.
What is that angle there?
So isn't it 90? Like, isn't x 90?
No,
X
it's
50.
80.
What is 360 minus 150?
210.
210. So x should be half of 210, right? Which is is it 105? Okay, so yeah, be careful there.